Thank you for joining us. Thank you for joining us tonight. I know you had a lot of things that you wanted to do, but you chose to be here with us, and we appreciate that. Thank you, Engineer Derry, for taking us through the first point. And of course, it's always good for engineers to discuss the contemporary issues that are affecting infrastructure development in our society. Drainage design is quite sensitive and sometimes people say it's quite a complex kind of a design, which I agree, because then it requires a very systemic kind of thinking where you integrate the various components and aspects to ultimately come up with a resilient infrastructure system that is expected to perform very well, even in the worst case scenario. Um, so these this program is meant to expose us to such issues and see how best can we address some of the issues that we are facing on a daily. So what I'm going to do is I'll share with you what we've prepared for you in this program, and then from there you can be able to see whether it is something that could be able to help you. Let me share my screen with you now. So, uh, okay, so let me share that. Let me share the screen with you. Great. Please, someone can confirm whether you are able to see my screen.
We can see it.
Very good. Thank you. So, welcome all. We'll go to our session. This is our information session, and it is basically meant to take us through a couple of things. And this is just like an orientation session to take you through some of the things that we are going to cover. And as we take you through this, we're going to be able to decide whether it's something that would be one of the skills that you want to put in your arsenal. So my name is James Moridi. My business is just grooming industry ready talent, and that is where we learn together. We build projects, we build skills, we build uh, performing personality. And then lastly, that is going to lead to transformation of not only your career, not only your mind, but also the society at large, because our job as engineers is to serve the society. So I go straight to the common challenges, for example, that many drainage engineers face. Actually, this is extracted directly from the forms that you fill when you're applying for these very same course. Some of the challenges that you face. One is difficult linking rainfall data to design models. And I think this has been a limitation in a lot of drainage design softwares. So, for example, if you go to Civil 3D and you want to design drainage systems, sometimes it's very difficult for you to link rainfall data, actual rainfall data, into your design model. And therefore, it's a problem because you will just be having systems, you're just sizing, but ideally you cannot be able to simulate how, for example, such a drain is going to form. So you cannot know whether your drainage will surcharge or will they be flooding. So you just trust the calculations you did and that's it. The second one is what we call also limited rainfall data. I think in Africa we really struggle with preservation of long term data sets. So, for example, you are in Kenya, getting rainfall data from the Met Department is a pain. You 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 have to do a lot. Whereas when you go to countries like Australia, uh, New Zealand, the Americas, and such other countries, you can easily be able to find rainfall data with a click of a button. They are available just for public and, of course, for professionals to utilize them in design. You will also notice that when it comes to what we call rainfall methodologies, a lot of rainfall methodologies that we have are foreign. They are not African. So, for example, you will find there is the FEH, there is the SES for the Americas, there is NOAAH for the Americas. I mean, there is no specific rainfall model that is customized and meant to predict the events that we have here in Africa. And therefore, when we use their models to simulate our events, ideally, you expect that the chances of failure are, significant, so to speak. There is limited exposure to practical design workflows. So some of us are just like, there is no standard approach for many scenarios. I think one of the only models that I've seen that at least tries to look into our scenario is the TRLL model, which was developed again in the UK, and then it was they came and did a research, and we have an East African kind of a model just to help us in drainage design. So this exposure is very limited and therefore becomes a problem to many of us. There is also lack of confidence in hydraulic and hydrological calculations. Sometimes we don't know how they should be done. So we are just, there is no confidence really in how this hydrological and hydraulic analysis is done. And therefore, that then, if there is a doubt in terms of the professionals, it means that also even the system itself may not necessarily, we may not be very necessarily comfortable with the kind of system that we are developing. It also means the need for guidance on interpreting design standards. You will notice that also some of the countries, as we're speaking, for example, in Kenya, imagine for all these years, it is only in 2025 that we've been able to develop a drainage design model or a drainage design manual. And if you keenly look at that drainage design manual, it is borrowing so much again from those other countries. And therefore, you have very little to say that this is a Kenyan and it's looking into the Kenyan context. I don't know about your country, but somehow, even in the previous programs that we've done with a lot of engineers from different countries, they have found that even in their own countries, some countries don't yet have any drainage design standards that can be able to guide engineers as they do practice. And those gaps are very significant. There is also inadequate mentorship, instruction, and training. We have a lot of senior professionals who have done drainage models that have performed in a lot of places. But they die with that knowledge. And also, I don't know whether this is my personal observation. The older generation of engineers has been gatekeeping knowledge, honestly. I mean, when someone knows something, that's it. They don't feel like they can share. They feel like that is the advantage that they should have. I think it is the boomers, the millennials, they were living in the world of competition. So you are competing. So when your mindset is about competition and not collaboration and growth, that is when you start hoarding information. You start gatekeeping information so that now you can be told you are the most brilliant. Now you're the one who will be sought after. It's a very selfish human nature. That is, of course, even with some of us. But I think we need to go beyond that. such that if you understand a principle, if you understand something, if you discover something that is easy and making the work of other engineers easier, I think it could only be human for you to be able to share it out so that other people can be able to learn. There are many other challenges, but I hope you can be able to share with us and we discuss them. But these are just but a couple of them, couple of challenges, just a couple of them that we are facing as drainage design engineers. If you look forward to around 2050, I want you to imagine 2050 how your city will look like. Now, put yourself in the shoes or teleport yourself to 2050. So, like the gentleman here who was speaking called Derry, in 2050, he will possibly be around 55 years. He will be in his prime and he will be most possibly in the management level. So the way now we are blaming, the national government, the PS for, for transport, the regional director for some authority, the governor for some city, the city planner for some, for your city. We will be at that point in time. We are the people now that the younger generation who will be our age. They will be looking up to us. They will be demanding solutions just like we are demanding solutions from our seniors at this point. We will be most possibly living in an area where there is smart and resilient drainage system. They will be needed. We will be living in an era where sustainable stormwater management is not an option, but a compulsory aspect. We will be living in an era where reusing and recycling water will be culture that is already in our society. We will be living in an area where we must have clean and well-planned urban layouts, whereby urban planning will be compulsory. I think I was discussing with one of my colleagues this morning. We were at some nice restaurant having tea, and we were saying, "Yo, look at this restaurant! It's so amazing! It's beautiful." You know, people who are walking in there, they are very, very, very well, very, very well off people. But when you step out of that, and we were saying, if it happens to rain right now, stepping out of this restaurant, you feel like you're coming from a slum. Because once you get to the road, there is sewer passing by here. There will be too much storm water. There will be flooding everywhere. And how did we get to see such situations? We got here because even when it comes to developers submitting their plans to county government, to the municipalities, they don't care about drainage. Actually, they do for approval. If my brothers and sisters, you went to your municipalities and local authorities, you will find one of the best drainage designs there. You will find we have so perfect designs on paper. But when it comes to implementation on site, we don't care. We have seen that in our authorities, the road agencies and authorities, in private development, and even in ethics. So it is not like we are horrible. It is not like the design aspect is very poor. We really have somehow designs that are somehow at a good level, but the implementation is a problem. That is why, let me tell you, that is why you will notice, for example, in very good and well implemented cities and residential places here in Nairobi or even in your country, they do not flood. So, for example, if we go to a city like Konza City here in Kenya, those people are serious, are not only serious in terms of approvals and designs, are also very serious when it comes to implementation. If you go to a place like an estate here in Nairobi called Nyari Estate, those people are not only strict on how you develop your property, but are also very strict in terms of implementation. But when you come to your local neighborhood, the county officers who come to supervise, I think even here in Kenya, kind of officers that we have as part of disaster management and emergency response is some pastor who has done some theology. I think I saw that trending, and you're like, how do we even get to such levels? When it comes to implementation on site, we are very quick to give bribes so that we don't do some aspects, or so that the supervising officers can be able to overlook some aspects of design. So for me, actually, while there is an issue in terms of drainage systems in preparation and such, the bigger aspect is the decay in the moral, ethical, professional practice in our respective countries. And this does not have to continue. As we proceed, as we grow as engineers, I think it is high time that we become ethical professionals. And it starts with you where you are as a junior engineer, and you know what happens in that side. Now, as we prepare ourselves to this future that we are looking forward to, where we'll be having smart and resilient drainage systems, where we'll be having maybe cities that have sustainable stormwater management, where we'll be having data-driven urban planning, and we will be having green infrastructure and livable spaces. These are some of the skills that I think you may need at this very stage where you are in your career now, even before you move to those levels. Number one, if you really need to be good in drainage design, you need to understand hydrological and hydraulic analysis, design and analysis. How is it done? What are some of the tools that we can use for hydrological and hydraulic analysis? That is very important. So, for example, you notice that in this case, you can be using softwares like um, uh, Info Drainage, which I think is a great improvement. It uses the the SWIM model for hydrological and hydraulic analysis. It has the capability to integrate the catchment properties, rainfall data into the model, and then simulate how your drainage system is going to perform. We need to move away from the use of open channels in most cases to a bit more um, uh, uh, into more kind of drainage systems, which I think are happening in a lot of cities, so that then they are underground and we can utilize the upper part of or we can be able to utilize the surface for reasons and purposes. The second is the ability to improve simulation and modeling of stormwater systems. So can you be able to model and simulate how this drainage system is going to perform in real time? How can you be able to do that? The third one is the integration of sustainable drainage systems. So, for example, you notice that in the modern era, a lot of drainage design, we are integrating storm drains, we are integrating uh, swells, we're integrating different other green infrastructure into our design. And then after that, can you be able to make better decisions using digital tools and contextually as we do the application? I think when it comes to buildings and building development and structural design, as Africa, we are doing fairly well. When it comes to road designs, we are doing fairly well. But when it comes to drainage design, we are yet to be able to make very, very smart uh, engineering decisions using the various tools. And then lastly, after you apply hydrological and hydraulic design, after you do the modeling and simulation, and then after you integrate the various sustainability principles, after making decisions, and then lastly, we need to be able to apply and prepare professional drainage design documentation. These are some of the skills that you'll be learning and the competencies that you will develop in this program. So the question then is, how are we going to approach this? The first thing that we're going to do, I want us to start on the very first end. We will start with analyzing rainfall data so that we can be able to determine the design discharges that were needed in the various locations. Now, you'll notice that rainfall data is very scarce. We will be using some online sources, which are secondary sources, because, for example, when it comes to, for example, design of utilization of IDF curves to estimate rainfall intensities, you need data for like 30 years. If you go to our local meteorological department and ask them for a data for the past 30 years, they will be as surprised as yourself. They'll be wondering, where do you think we can get this data from? So there is that inconsistency in terms of data. So in this scenario, we're going to be using some satellite data to be able to simulate such scenarios. And then after that, we can be able to design drainage systems. This is modeling now. After we get our drainage data, our rainfall data, we can be able to, model our various drainage systems. So this starts from what we call the catchment areas. And then after the catchment areas, and we have the discharge design, we can be able now to know what are some of the systems that we need to use. So are we going to use piped channels, storm drains, or are we going to, utilize open channels and so on? How do we approach design for such systems? And then we'll be looking at how do we apply the various design standards. So there are various international standards that are used for drainage design, which I think are very significant and should be, looked into. So we can be able to do that together with all of you here. So the other aspect that we'll be doing is, of course, integrating the green infrastructure. This one is mostly done into info drainage, where you can be able to integrate the soils and such other, which are basically the outlet for our stormwater. And then lastly, we'll be able to prepare construction drawings. And in the construction drawings, after preparing the construction drawings, will be done. So ideally, we are doing 1, 2, 3, 4, 5, 6 items into this course. Those are the 6 key items that we'll be looking at. The tools of work that we'll be utilizing in this course are, of course, this one was supposed to be AutoCAD, Autodesk Civil 3D, sorry. This part here. This is supposed to be Civil 3D. Then we'll be also looking at a tool called Info Drainage. Info Drainage is a tool that has been designed specifically for stormwater design and sewer design. Civil 3D also has the aspect of the pipe networks, which are quite superior when it comes to design. So those are the tools we'll be using. We'll be using a lot of Excel work here. These are Excel templates that are used in, calculation of catchment, runoff in the catchment. Then after that, of course, you need to have a brain and your hands, and that is a good coordination. Then after that, those are the basic tools that we need to use. And then after that, again, we will be able to done with that part. So I will take you briefly through our course outline so that you can possibly be aware of some of the things that we'll be looking at. Let me see whether I have it here. Yes, the course outline is with me here. So let me share. I know you are not able to see it for now. Let me share it with you. So this is the urban drainage design course. The course is designed for civil engineers, drainage design engineers, infrastructure persons that are practicing, and you want to have more of a data-driven approach to the design of drainage systems. It will be a 5 weeks online training, which will be practical and, of course, equipping you with the various software expertise required to design effective drainage and stormwater management system that can be applied either in roadworks, highways, estates, or even in urban areas. The course is going to integrate hydrology. That is, of course, the aspect of rainfall, analysis and runoff analysis. We look at hydraulic modeling, which is basically the principles of how water flows in various channels and conduits. So that could be maybe how water behaves in open channels, in closed channels, or what we call pipes and conduits. And of course, the tools that we'll be looking at is Civil 3D, info drainage, and of course GIS tools to enable data-driven and sustainable infrastructure training. The course objectives are very simple and straightforward. They are actually six, just like I've told you before. The first one is, of course, how to be able to analyze rainfall, runoff processes, and be able to determine the discharges, the design discharge. And then after that, we can be able to size side drains and storm sewer pipes for various applications. And then after that, we are going to model. After designing now, we model those storm sewer systems in Civil 3D and info drainage. There's the two tools are very interoperable. So you can be able to model in Civil 3D, export it into info drainage, and then export it back into Civil 3D for refinement. We'll also be looking at how to apply the various design standards. In this case, I would recommend that you look at the local design standard in your country. Maybe that could be of help. And then lastly, we see how we integrate the various sustainable drainage infrastructure. And after that, we'll be able to prepare the construction drawings and reports for implementation. The course will be delivered online through Zoom, just like we are doing now. You'll be receiving recorded tutorials and, of course, project-based assignments or milestones that ensures that you are able to apply the knowledge learned after every class. After that, you will receive design data sets, the reading materials and manuals. And of course, also you'll be getting feedback on your work as you progress to work on it. The time of training is 8 p.m., just like the time you joined in here. And that is the same time the classes will be starting. And the days of training will be on Monday and Wednesday. Monday and Wednesday. Monday and Wednesday. Just 2 days in a week. 2 days in a week. The reason as to why we are doing that is because some of the work is a bit involving and you may need a little bit some time to be able to work on it. Additionally, you'll notice that the kind of people who are doing such a course like this one, they are quite busy and engaged with other things. And therefore, we really do not intend to bombard you with a lot of classes. 2 classes in a week will be fine. And therefore, we'll be able to do 10 sessions until completion of this program. The first module will be Introduction to Sustainable Urban Water Systems. So this is where we will be able to understand what we call the hydrological cycle and the water cycle rather in urban areas, and how the climate change is affecting rainfall and runoff in urban areas, and how human alteration of the water cycle. So how are humans affecting the water cycle in a manner that it is affecting how runoff, how the natural system is supposed to work. So, for example, one of the human alterations that you notice is our urban areas are concrete jungles. The impervious sections are increasing significantly to almost even 80%. And therefore, you notice now that results to a lot of runoff because the water will not be able to be infiltrated into the ground. And that is why we always have higher volumes of runoff in urban areas compared to rural areas. The second module will be on hydrological survey and flood estimation. So this is where we look at the basic design process for urban, the basic design process for flood estimation. We'll be looking at hydrology and planning. We'll look at how hydrological data is collected. We'll see how we make choices for the various drainage systems. And then lastly, we'll be able to do what we call flood estimation for standing catchment. So when we talk about flood estimation, you can also talk about the distance design estimations. We'll be, of course, working with GIS tools and data exchange and terrain modeling because we will need, of course, topographic data to model our digital terrain. So that is important, and already there's a set of data that we'll have access to. And of course, we'll be using Civil 3D for the part of, designing or modeling our existing grounds and of course laying out our various pipes and models. The second one will be the highway drainage components. This is where we'll do design of open channels and side drains, and also we'll be able to do uh, the design of pipe networks as components along our highway sections as part of the drainage components. Then after that, we go to the third module, which is the design of sustainable urban drainage systems. Again, we'll look at the rational method. And in the rational method, that is the main method that we can apply when it comes to the design of urban areas, especially in sections that are less than 5 kilometers square. And then we will be looking at the various ITF curves and design hydrograph. And then after that, we'll be able to lay out our urban drainage networks. These may include storm drainage and storm drains, sizing of drainage channels and drainage pipe networks, and how do we arrive at sizing them. We'll then do an analysis of the network and of course optimization and do the reporting. After that, we will get to look at this a new module we are introducing, the design of culverts. I think it's something that was not covered in the previous course. So this time we'll be looking at how can we be able to design the various pipe culverts that could be installed in various sections of our roadway. So look at the types, design criteria, and considerations for culverts. We look at the inlet and outlet control. We'll be using the Manning's equation. Of course, that's the most common equation when it comes to the design of culverts. I will be looking at how we use nomographs for culvert design. And then, of course, we will be able to complete the design of a pipe culvert in that module. Then the last week of this, which is week 5, and of course, we always say that there is an provision for one more week, week 6. This is where you'll be working on a capstone project. There's a site that we work with that is called Soisambu. That is what we've been working with the previous cohort. But for you, you will be working on another project from South Africa. And in this project, we will be designing a drainage system all around it. So it is it's around a 2 hectares size of urban area. We are converting to be a complete urban area. So the idea is again for us to be able to know how could we apply this knowledge contextually and directly to a given project. This week 5 is basically for you to apply all the things you've been learning in the previous weeks, and of course be able to complete a project, so to speak. We'll have the various reference materials. We'll be looking at the Kenya Urban Drainage Design Manual. We'll be looking at the Syria. This is more of the UK model. We'll be looking at hydrological manuals here and there. We'll be looking at EC 2022 and Urban Drainage Design. This is a book on urban drainage design in the 4th edition. It is a US-based kind of a model, and we'll be comparing that. When it comes to the software to be used, we are going to use Info Drainage, Autodesk Civil 3D, and of course, Google Earth Pro for visualization. So that is basically what the course entails. And I will be open if there are questions and if there is need for clarification, I can be able to give clarification now as we proceed. So the course is supposed to start next week. I think it's on 12. Let me check my calendar. It says it's on 12. That is when the program is meant to start. Today was just an information session. It's important for you to know that we provide all these softwares that you need, so you don't need to worry about them. And the learning resources, all learning resources are provided, starting from the softwares, the learning materials, and of course, lastly, the design asset. I don't know whether Captain West is here with us. He can be able to guide us on how to acquire the softwares, but I think he is not here with us because there's another class that he is leading. So I'm open to any questions before we call it a day. So please, if you have any questions, let me know. Any questions or need for clarification?
Can you can you hear me?
Yes, please.
Yes, my question is about contour lines. Are we also going to be learning contour lines? Because I believe that is part of learning how the flow of water is going to be.
Contour lines.
Yes, the
Yes,
natural.
definitely. When we are doing existing terrain modeling, we'll be looking at those contours, yes.
Okay, thank you.
Any other question?
Hello.
Very good. Yes, please.
Yes, good evening.
Good evening.
Yes, I'm Daniel. I happen to be one of the previous Rivet boot camps, which has just ended last month. Now for this, I've not interacted with Silver 3D. Would this be also fit for me also, or it first need to first interact with Silver 3D? Then we can go on, maybe. I don't know.
Okay, great. I would recommend that you have some foundational knowledge on Civil 3D. Yes, I would recommend you have foundational knowledge. But then again, it is not like it's a completely uh, a difficult kind of a program. It's only that if you don't have prior knowledge utilizing Civil 3D, you may need to go an extra mile to, you know, to put in a bit of effort than most of the people who are comfortable with the software before. Okay, so there will be a couple of templates that we'll give to you. Like the first template is for developing IDF curves. The second one is for estimating design discharge. The third one is for the design of pen channels. And then, yeah, those are the three major templates uh, that you need for this design, but they shall all be provided for you, so you do not have to worry. So if you are yet to, for example, if you would want to join us, and maybe you are yet to be here with us, what I recommend is you can go to our website, just go to RoneSub, and then go to courses. This thing nowadays is asking me whether I'm not a robot. I don't know. Thinks I'm a robot. So you can go to our courses and you will notice there is the urban drainage design, and you just click on that and you proceed to, to purchase the course directly from the website. It shouldn't be much of an hassle. You just proceed to purchase it. So I think this one I purchased so many of them. So you can purchase directly on our website. Please use your bank card. It is totally safe. People have been using it for a long time, and it has not brought any problems to any of us. So what you can do is use the first option for PesaPal that has the various Visa card, MasterCard, American Express, and all of this. And you just place your order. You can input your card details. You can be 100% sure that we are not necessarily accessing your bank or your card data. This is a protected system. If you are in Kenya, you can use M-Pesa or Airtel Money. If you are outside Kenya, please use the Visa card here. So with the Visa card, you can input all these card numbers and such other information and proceed to make payment. If you have any challenges, please feel free to reach out. And by reaching out, you can just, if you're stuck here, just click on this WhatsApp icon and you can be able to open a chat and, and text us directly. You can text us directly and we will be able to respond to you on time. So that is it from me. Thank you very much. Mm, uh, Thank you very much. I think that is it from my end. And just make the right decision. And once you make the right decision, then you can let us know if you would want to be part of the course. The course starts on 12th of May, that is next week. And this weekend, I would recommend if you are to join, you can make your payment this weekend so that then at least we will be able to sort the software issues before we get to the course. So thank you very much. I hope you have understood what the course entails. I will be able to send the course outline to you via email tomorrow. Of course, as also with the recording for this session, so that then you can be able to look at it and make the right decision. So thank you for having me. I will hand over back the session to Derek so that he can conclude it. Engineer Derek, please. Thank you.
Thank you, Engineer. And thank you for explaining to us what the course entails, so that as we dive into it, we have a roadmap on what we are supposed to cover and expected outcomes of the training. There was a question in the chat box from Thomas. I hope that your question has been addressed by engineer's response to Daniel. I think it's the similar case. Yeah, you just have to go an extra mile, but it's something that you can manage. Yeah, because that's the price we have to pay in the pursuit of knowledge. Once again, I want to thank you all for showing up in today's session. For those who have already subscribed to the training and I have onboarded them, please go ahead and download the softwares as guided in the message we shared earlier. And once you're done with downloading the softwares, please reach out to the tagged contact. He will help you in obtaining the licenses and having them fully installed and functional. Thank you all for showing up today and taking time and interacting with us, asking us questions. I hope to see you as we kick off the session on Monday. Have a good night and a nice rest of the week. Thank you all very much.